Hello everyone. In this lecture we are going to verify the law of conservation of energy. So the law of conservation of energy states that energy can neither be created nor be destroyed. It can only be transformed from one form to another. So let's verify this law using the two energy we know, that is the potential energy and the kinetic energy. So suppose there is a ball and this is the ground. This ball is at a height h from the ground. So at this point, this ball will have the potential energy equal to mg h. This is the potential energy of any object at a certain distance from the ground. So let's suppose at a time t, this ball is dropped downward. And it reaches a distance p, which is at a height of x from the ground. Okay, so at the point p, at this point the ball will have the kinetic energy as well as potential energy. So the kinetic energy of the ball at this point p will be half m v square, and its potential energy at this point p will be mg x. We are using the plus sign here means because at this point this ball will possess both the energies, the kinetic energy as well as the potential energy. So here we need to first calculate the v using the Newton's equation of let's consider it as equation 1. V square equal to u square plus 2g h minus x. Here initial velocity will be 0 because initially the ball was at rest condition at the height h, and here we are considering the distance as h minus x because at a particular time interval the ball has moved to a distance h minus x from the top portion. Okay, so when we solve this we get b square equal to 2gh minus 2gx. So when we substitute the value of v square in this equation of complete energy of the ball of equation 1, we get half m, instead of v square we will write 2gh minus 2gx. This is the kinetic energy part plus the potential energy part. So when we simplify this we get half m 2gh minus half m 2gx plus mgx. So 2 will cancel out and the equation will become mgh minus mgx plus mgx will cancel out, and here it will again become mgh at the point P. That means initially at the top its potential energy was mgh, and we also found out that at the point P also the potential energy has come out to be mgh, so it verifies the law of conservation of energy. Thank you.